Welcome to the new Learn With Me playlist on the Science Revision Coach channel. This playlist will feature videos that will explain some difficult science concepts and processes. This Learn With Me video will cover the AQA Combined Science GCSE topics on Quantitative Chemistry. It is applicable to both the Combined Chemistry unit and the Separate Science Chemistry unit. It will cover a lot of the higher tier requirements in the specification. This video will show you how to calculate the relative atomic mass, calculate the relative formula mass, calculate moles for higher tier, predict the masses of reactants needed or products made for higher tier, predicting limiting reactants for higher tier, working out the empirical formulae for higher tier, calculating percentage composition for higher tier, and calculating percentage yield for higher tier. The relative atomic mass is the mass number of an element, essentially, which can be found on the periodic table. It is always the larger number in the tile on the periodic table. For example, the relative atomic mass of sodium is 23, the relative atomic mass of magnesium is 24, and the relative atomic mass of copper is 63.5. Find the relative atomic mass of the following: neon, iron, and zinc. Pause the video so that you can find this out on a periodic table to hand. So you should have found out that the relative atomic mass of neon is 20, the relative atomic mass of iron is 56, and the relative atomic mass of zinc is 65. Right, relative formula mass is also known as the relative molecular mass, and it is the sum of all the relative atomic masses of all the atoms within a molecule. For example, the relative formula mass of water is: the relative atomic mass of hydrogen is 1, the relative atomic mass of oxygen is 16, therefore the relative formula mass of water is going to be 1 plus 1, because there are 2 hydrogens in a water molecule, plus 16 to give a total of 18. The relative formula mass of sodium hydroxide is 23 plus 16 plus 1 to give a total of 40. What is the relative formula mass of calcium carbonate? Pause the video so you can calculate this yourself. The answer is 100, and you should have been able to work that out because calcium has a relative atomic mass of 40, carbon has a relative atomic mass of 12, and there are 3 oxygens which each have a relative atomic mass of 16. Moles. The number of particles or atoms or molecules or ions in a chemical substance species can be quantified using the unit mole. 1 mole is equal to 6.02 times 10 to the power of 23 particles. This is a really big number. This number is also known as Avogadro's constant. The number of moles of a substance is equal to the mass in grams divided by the molar mass. Now, the molar mass is similar to the relative formula mass of a molecule. The way to think about moles is, obviously, it is not a furry animal that lives underground in chemistry. It is a unit of measurement. And just think about trying to count the number of water molecules in a bucket of water. That would be impossible. There will just be billions and trillions of water molecules in one bucket of water. But if you could actually count the number of buckets, that's a lot easier. That is doable. That is manageable. So you can count the number of buckets, and that's a lot easier for chemists to work with. So the mole is the equivalent of a bucket. That's another analogy to think about it to help you to understand. On the screen at the top, you can also see the equation to calculate a mole. So you can actually work out the number of individual chemical particles such as atoms, molecules or ions if you really wanted to. You would need to know the mass in grams. You would need to know the molar mass, which is like the formula mass, relative formula mass that we've just calculated. And you can use the triangle on the board or on the screen or the equation. Moles is equal to the mass in grams divided by the molar mass, and you can work out the number of moles. And because you know what Avogadro's constant is, you can work out the actual number of atoms or molecules or ions that you are trying to calculate. Key steps in calculating unknown masses. Firstly, you have to write a balanced equation. Secondly, you need to write any masses that you've been given and any masses that you are asked to find out, so your known and unknown masses. Thirdly, you need to write down the molar mass of known and unknown species. So whatever you've been asked to find out and whatever you've been given the mass of, you need to write down the molar mass, which again is the relative formula mass of any if it's a molecule, or the relative atomic mass if it's just an element. Fourth, calculate the moles of the known mass. You can only do this with the known mass, so therefore you use the moles equation that was on the previous slide. In fifth step, you need to use balanced equation coefficients to calculate the moles of unknown mass, and this is basically the mole of the known mass times the coefficient of the unknown divided by the coefficient of the known mass. And just to remind you, the coefficient is the big number to the left of the chemical. Step 6, rearrange the mole equation to calculate mass. And to calculate mass using the mole equation will equal moles times the molar mass. And the moles is what you've just calculated, and the molar mass is what you can find out using the periodic table and the relative atomic masses of the atoms involved. And step 7, you can make a revision tool using sticky notes and a flowchart template to memorize these steps. Check out this method on the Revise With Me playlist on this channel to make your own version of a revision tool to remember these steps. So here's an example. We write a balanced equation. So this is the equation that the exam question has given me. Calcium plus water produces calcium hydroxide and hydrogen gas. So I've written the state symbols. I now have to balance the equation. And after balancing it, I can see that I've got 2 water molecules to every 1 calcium. Then I have to write down known and unknown masses that were given. So I've been given calcium hydroxide of 2.8 grams, and I've been asked to find out what mass of calcium needs to react to form that 2.8 grams. I now write down the molar masses of my calcium, which is unknown, and my calcium hydroxide, which I do know the mass of. So I've got 40 for calcium as the molar mass, and I've got 74 for the molar mass of calcium hydroxide. And now I can calculate the moles of my calcium hydroxide because I know the mass of it. And I've worked it out to 0.038 moles, and I've rounded it up to 2 significant figures because I have 2 significant figures given for my original mass. Step 5, I'm now going to use my balanced equation coefficients, and the coefficients, as you can see, I've underlined, are the numbers to the left of the chemical. So obviously where it's just 1, we don't typically write the number 1. So I've got 1 calcium, 2 for water, 1 for calcium hydroxide, and 1 for hydrogen gas. And then I've got to use the equation in the brackets. So the moles of the known mass, which I've just worked out as 0.038, I've got to multiply it by the coefficient of the unknown, which is going to be 1. And I'm going to divide it by the coefficient of the known mass, which is also going to be 1. And what I get is this equation, which tells me that I have 0.038 moles of calcium. Now, for those of you who are quite good with ratios, you would have seen from the balanced equation that I have a 1-to-1 ratio of my unknown calcium with my known calcium hydroxide mass. So if I have 1 mole of calcium hydroxide, I must have 1 mole of calcium. So if you couldn't see that, use the equation in step 5. Step 6, I now rearrange my mole equation to work out the mass of my calcium, because now I do have the number of moles, I have the molar mass, I can now work out the mass in grams. So I just multiply my number of moles, 0.038, by 40 to get 1.5 grams of calcium. Here's another example. I write my balanced equation. Sodium hydroxide plus chlorine to produce bleach plus sodium chloride plus water, and I write the known and unknown masses given after I've balanced it, and I can see that I've been told that I need to make 5 grams of bleach, but I need to know how much sodium hydroxide I need to react with chlorine. I now write my molar mass of the known and unknown species, and I can see that I have a molar mass of 57 for sodium hydroxide and 74.5 for sodium hypochlorite, which is basically bleach. And then I write down my moles that I can calculate of my bleach, which is 0.067 moles. I then use my equation, so I look at the coefficients of my unknown and my known, and I put them into the equation so that I've got the number of moles of my known mass, which is 0.067, and I'm going to multiply that by the coefficient of my unknown, which is 2 for sodium hydroxide, and then I'm going to divide that by 1, which is the coefficient of the bleach. So I get an answer of 0.13 moles of sodium hydroxide is needed. And again, for those of you who are good with ratios, you will see that there is a 2-to-1 ratio between my sodium hydroxide and my bleach. Therefore, if I have 1 mole of my bleach, I need to multiply that by 2 to get the number of moles of my sodium hydroxide, which is what I have. I then rearrange the mole equation and multiply my number of moles that I've just calculated in step 5 by 57 to get my mass of sodium hydroxide, because the molar mass of sodium hydroxide was 57 as I calculated in step 3. So hopefully now you've seen 2 examples using the same steps, and the key thing is if you memorize the steps and you do lots of practice, these kind of questions are actually fairly straightforward and quite easy. The most difficult part would probably be step 5 and knowing what the ratios are, and I've tried to make it as very clear how to work that out, even if you struggle to appreciate how the ratios work. Right, predicting limiting reactants. In this situation, you have to really read the question and make sure that you understand what the question is asking you for. So typically in these types of questions, unlike with the calculating unknown masses, in the unknown masses there's always a mass that they want you to find out. They will say how much mass of such and such is produced. In a limiting reactants question, they will tell you the 2 masses, but they want you to find out which one is limiting, which one is in excess. So first thing you do again is you write a balanced equation. So I write the equation that I was given. Aluminium plus iron 3 oxide produces iron and aluminium oxide. And I can see that I need to put coefficients 2 in front of aluminium and iron. I now write down the masses that I've been given. So in this question, I can see that I've been given 16.2 grams of aluminium and 32 grams of iron 3 oxide. Now, in an exam question, I would be annotating this on the paper, and I cannot stress this enough. In all of these questions, you need to be annotating on your exam paper. Step 3, I write down the molar mass of the species involved. So I write down the molar mass for aluminium and for iron 3 oxide. And in step 4, I calculate the number of moles of those masses. And I can see I've got 0.6 moles of aluminium and 0.2 moles of iron 3 oxide with the masses that they gave me. Now, in the question, they asked me which one was in excess and which one was the limiting reagent. So what I have to do is I have to look at the coefficients of the known masses. So I have to look at iron and aluminium, and I've just written the coefficient for iron. So it's a 2-to-1 ratio according to the balanced equation. So that means for every 2 aluminium, I need to have at least 1 iron 3 oxide for the reaction to occur. And when I look at what I've actually calculated, basically I've got 0.6 moles of aluminium. So therefore, if it's a 2-to-1 ratio, I would need a minimum of 0.3 moles of iron 3 oxide for the reaction to occur and in its entirety. But I do not have 0.3 moles of iron 3 oxide. I've only got 0.2 moles of iron 3 oxide. So you should be able to see now that I have identified that aluminium is in excess and iron 3 oxide is the limiting reagent. And when I'm doing an exam question like this, I have to explicitly state that. I can't just assume the examiner is going to work it out from my calculations. You've got to actually state that as a final sentence after showing you're working out. And another thing I just want to add right now is if you show you're working out or lay out your working out like I have done, you cannot lose marks. Right, empirical formulae. These kind of questions, very rarely in the recent past have I seen them use the term empirical formulae, but it is slightly different from the calculating unknown masses questions and the predicting which ones are limiting reagents and which ones are in excess, because they give you all the masses and they can give you the masses in grams or percentages, so be wary of that. If they give you the mass in, if they tell you that there's this percentage of this element, just convert it into grams, just assume that it's in grams. And they want you basically to work out what the ratios are, what the coefficients are. So they basically want you to try and work out the balanced equation from the mass. So what you do in this case, compared to all the other steps we've just looked at, you're going to write the symbol equation, but you're not going to balance it. Okay, so that's really important. So in this particular example, I've been given sodium nitrate, and that breaks down to form sodium nitrite and oxygen. I write down all the masses given, so they've told me all the masses, so that should straight away make me think this is not trying to work out unknown masses, because I've got all the masses. Step 3, I need to find out, so from now on it's typical, it's similar process. So I write down the molar mass of all the species involved. So 85 is the molar mass for sodium nitrate, 69 is the molar mass for sodium nitrite, and 32 is the molar mass for oxygen. And then I can calculate the number of moles as usual. And then now we slightly do a different step. Now we are using ratios again. So what I have to do now is I have to identify the smallest mole, and I've identified it as 0.05 for oxygen. And I'm now going to, in step 5, divide all of the other moles by 0.05. So I will get an answer of 2 for sodium nitrate, 2 for sodium nitrite, and 1 for oxygen. So it's a 2-to-2-to-1 ratio. And you can see in red where I've put those coefficients. So now I can put them into my formula to actually show the ratios as coefficients. And that is essentially how you work out the empirical formulae. Now this can be done not just to balance an equation, it can also be done to work out what the formula mass is of a chemical. So instead of given a chemical equation, you may just be given the percentage or the mass of individual elements, and you need to work out what the chemical formula is of how those atoms are arranged in a molecule. So how many aluminiums in how many ions in iron 3 oxide, for example. Is it iron 3 oxide or is it iron 2 oxide? Is it water or is it hydrogen peroxide, for example? And this is where this type of working out will help you to decide this. Right, percentage composition. So this is how much of a molecule is made up of a particular element. The equation is the relative atomic mass of the element in question divided by the molar mass or the relative formula mass of the whole molecule, and then you multiply that by 100. So for example, the percentage composition of sodium in sodium hydroxide is 23 divided by 40, because 23 is the relative atomic mass of sodium and 40 is the relative formula mass of sodium hydroxide. And then I multiply that by 100 and I get an answer of 56%. So basically 56% of sodium hydroxide is sodium. So what is the percentage composition of the following? Can you work these out? Calcium in calcium carbonate, carbon in methane. Pause the video now so you can work out the answers. Okay, so you should have found out that 40% of calcium carbonate is calcium and 75% of methane is carbon. Right, percentage yield. This is how much useful product is actually made as a proportion of how much was theoretically calculated. So these questions may come up at the end of a trying to work out reacting masses type question. The equation needed is the actual yield, so how much you actually recovered, divided by the theoretical yield, so how much you predicted you would make, and you multiply that by 100 to get a percentage. For example, you would have a question asking you to calculate the theoretical yield using balanced equations to calculate the mass of a product. You are then told the actual mass of product collected and are asked to calculate the percentage yield of the product to determine the efficiency of the reaction. There are videos on the exam technique playlist on this channel that will show you how to answer quantitative chemistry exam questions. And if I give you an example from earlier on in this video, I calculated that 7.65 grams of sodium hydroxide was needed to react with chlorine to make 5 grams of bleach. I now could be told that only 4.87 grams of bleach was actually recovered from that reaction. The percentage yield would be 4.87 grams divided by 5 grams times by 100 to give a yield of 97.4%, for example. So it gives us an idea of how efficient the chemical reaction is. So now we've come to the end, just a little bit over 20 minutes. So thank you for learning with me with the Science Revision Coach. Please make sure you like, subscribe and share this video, and I will see you next time. Bye.